Hello and welcome to the Genomics channel. I'm Maria Nadestad and today I'm going to show you some quick, easy examples of how to use GNU parallel. And I'm going to show some basic, easy examples that you can play along with, and then at the end I'll show an example of how I use GNU parallel to orchestrate jobs for bioinformatics work. Now, as you follow along in this video, you might want to also be aware that I have the same examples and so on at omgenomics.com/parallel, and we have links to things like installation and so on here so that you can follow along as we go forward in this video. The first thing to do is to make sure that you have parallel on your computer if you want to follow along. So if you do this, it's going to give you some warnings and so on, but at least you'll know that it exists, and we can do Control-D to exit. Another thing I should mention is that sometimes there's something else called parallel on your computer that is not GNU parallel, so try doing parallel --help and grep for GNU and just make sure that that is in there. Because if it is not, then you probably have a different kind of parallel, which is not going to have the same features that I'm showing here, and you definitely want GNU parallel instead, so then you can just follow these installation steps to get the correct version of parallel and overwrite the one that's currently on your computer that is a different kind of parallel, perhaps. I saw this happen once, and it can be really confusing. So this is a good way to just check for that special case. Now that you have parallel on your computer, hopefully, so you can follow along, then let's start playing with it. So an easy way to test it is with echo, and you do parallel, you do the command you want to run, and then you do 3 colons, and then you want to do the things that you want to parallelize over. So here I'm going to echo A, echo B, echo C. So this is the same as basically typing out echo A, echo B, echo C. So it takes each of these terms that are after these colons and applies them like right after echo. So that happens automatically. You don't have to say where to put them. Other things you can do, of course, are this. We can do over anything that you want to put in here. Like you can use anything you want on the command line to do this. This is one that does a sequence of 10. So if I just do this, it'll print them, but this is also echoing them to the terminal. You can also get inputs from a file. So for instance, I could say cat file.txt, and this is one where I've already done like a seek 100 to file.txt. And so when we look at what's inside file.txt, it's this. And I could say parallel echo everything that is in file.txt. But instead of doing this, instead of doing cat, there is a shortcut for this because it's something you might want to do often, and it is to simply put 4 colons instead of 3 colons, and we get the same thing. You can get inputs from a pipe as well. So if I cat from this file, and let's say maybe I want to grep 2 out of that, let me show you what that looks like. And if I pass that to parallel, I'll echo hello, and then it's gonna put whatever else happens after this. Ta-da! So this is like a good simple example, I think. Now, turning the interestingness and difficulty up a little, let's play with combinations of arguments. So let me show you an example of that. So we want to do something for each of A, B, and C, but let's say I also want to combine that with 1, 2, and 3. So I want each combination of A with 1, 2, and 3, B with 1, 2, and 3, C with 1, 2, and 3. And that's what we get. So you can see it's doing every possible combination of those arguments. And that can be super helpful for a lot of things where you want to do experiments. Let's say different values of two different parameters in different combinations. So then you can do it this way. But let's say you want to link the inputs. So if you don't want every possible combination, you just want A1, B2, C3, you can do that as well. And you just use the -- link flag for that. Now let's say you want to run a script in parallel. So now we're getting to, we only used echo so far. These are just simple examples to show you how parallel works. But when you're really starting to use it for something, let's say vim do something.sh, and in here I have these file contents. So I set a variable called job ID, which is going to take the first argument. I sleep for 2 seconds and then say that the job is finished. So if you type that in, and I'm going to do :write quit here. I have a video as well on Vim, so I will put a link to that up at the top, or you can search my channel OM Genomics for how to edit files on the command line, or Vim, and you'll find the video if you need a refresher or an introduction to Vim. Okay, so now that we have the script, we want to make it executable, so we chmod +x, that makes it executable. Do something.sh. Nice. And now we can run it with parallel. So you do parallel, do something.sh, and you can run it for 1, 2, and 3, let's say. And so each one takes 2 seconds. They all run at once, and you can see that they might finish in different orders, not necessarily in the order in which you ran them. You can also add -- verbose, which shows you what is running, and then the script itself will print what it normally does, but this way you get to see what is actually running at the beginning. I would probably turn that on most of the time when you're doing actual work with parallel. It's a great parameter. You can also control how many jobs run at once. So if I want to say only run 2 of these at a time, let's say you only have 2 cores instead of more than 3, then this would be how you can make it only run 2 at a time. So you can see it starts 2 of them, those 2 finish, and as soon as one of them is finished, it launches the 3rd one and then finishes that. And of course, if you run it with --jobs1, then you're effectively doing the same thing as a for loop. Now let's try doing the same tricks, but with this other script called do something2.sh. And here it sleeps for a specified number of seconds. So let's also chmod +x, do something2.sh, nice. And I'll do this with verbose, do something2.sh, 1, 2, and 3. So they all start at once, and then you can see that the first one slept 1 second, second one slept 2 seconds, third one slept 3 seconds. Very nice. Other variations, I also have do something3.sh. This one has multiple arguments, so you can sleep for the specified number of seconds, and the second one will be like the name of the job. So what you do here to use it, of course, again, do this and parallel, and I'll do verbose again. Do something3.sh. So now we're doing our set of 2 different arguments again. Here again, we're going to do the combination of them. And that was really fast. Whoops. That is a teachable mistake right there. So I get a usage error from sleep that it's confused about something, but it's not terribly clear. But because I turned on verbose, I can see that it's giving A as the first argument and 1 as the second argument. Now if we go look at our dosomething3.sh file, you can see that it'll try to sleep for a number of seconds, because that's the first argument, and that's not good. So what we probably want to do is turn these around. So this is A, B, and C over here. And now it's working. Now we don't get the usage errors from sleep anymore, because we are sleeping for 1 second, not for a seconds, which obviously doesn't make any sense. So this is a good way, using verbose is a good way to just kind of check that what you're doing makes sense. And of course, if you're doing something inside of these scripts that is more costly, such as launching a job on a cluster or on the cloud, you probably want to employ some echo and stuff like that in the script instead of actually launching the job the first time, so that you can verify that what it is planning to do is correct and it makes sense and it is what you wanted. Going back to the example where we did this in the wrong order though, let's say you do want to keep this, but you just want to specify the order, or you might have flags where you're like, oh, I have my option 1, which I want, the 1, 2, and 3 to go into, and then maybe I want to insert them here. So the way that you do that, the way you decide where these should be inserted, and you can be much more explicit about this, is like this. So this number 2 will be the second set of arguments. That's where the 1, 2, 3 will go. And curly braces 1 is going to be where the A, B, and C will go, our first set of arguments. And so this is how you can do that. You could also set something like this if you wanted to use very explicit flags or anything, and you want these to be the values for specific things. Now you can control exactly where they go. So if we run this, we're again going to get the same as above, where we had fixed the order. So yeah, if you get the order right, then it just gets inserted. So by default, it's going to say curly braces 1, curly braces 2, curly braces 3, and so on. For however many arguments you put in, it's going to put it right after the command that you have here. Very nice. Now let's talk about running parallel with a function. So now I'm going to write a function, and one thing to note here is that I wouldn't usually just start typing a function into the command line. Even if I am going to copy paste it into the command line, I will usually want to write it in some other document first and then copy it in here. And by document, I mean text file. So in your text file, you can write down any function you want, and you can also go to omgenomics.com/parallel and just copy it from here. So we define a function called makeAFile. So the first argument is used for naming the file, and the second argument is used to determine how many numbers we are outputting. So we've copied this function into the command line. And one important thing to note is that you always need to do export-f of the function before you can use it in parallel. And now we can run the function like this. And here I'm using a few different tricks that I showed you already. And this is 10, 20, and 30. And okay, so if you're on ZSH like I am, it is likely that parallel won't work for you in this way. So what you can do instead is use env parallel. And this one is going to work with functions, and otherwise it's basically the same functionality as parallel. So this is just something that you might have to do if you're running parallel with functions. then, and you're on CSH like I am, and you get the same kind of error that I get when I try to do this with a function that you have exported first, then use env parallel instead. And the first time you do it, you have to follow some instructions about editing some config file. But now that I have it, it does work. And again, we see this kind of warning that we get from parallel, so I'm gonna Control D out of that, but at least now I've confirmed that env parallel works for me. So I still have my function called make a file, and now I'm gonna run it with env parallel, and I'm just gonna do it like this. Boom. And now I'm gonna look for all my numbers files. And we have numbers A, numbers B, numbers C, .txt. So those are the names. And yeah, so here I had that function which it uses the first argument, which is going to be ABC as the names for the file, and the second one it goes seek 10, seek 20, seek 30. Oh yeah, and if env parallel also isn't working for you, then of course you can Google your error messages and things like that, try to find other answers, or as another option is you just make a script instead of a function when you're going to do this. Functions can be kind of helpful because it's nice to just be able to copy paste into the command line what I want to do instead of storing the script somewhere outside of my notes. And I always work off of notes. I have another video on that that I will also link up above here, called How I Organize My Bioinformatics Work. So check that out if you haven't already. But yeah, you can always just default to using scripts like we did with the do something scripts before. Okay, so now we get to the part where I want to show you how I use Parallel for orchestrating, like launching bioinformatics jobs. What I would do is basically use Parallel to launch different instances of a script. And so I've made an example of that here. So let's create some fake BAM files. So touch just creates the file but doesn't write anything to it. And that's just so that we have some fake input files that we can play with. So this is a typical kind of runner script that you might want to have. It takes some kind of input. There might be some other parameter that you want to test different values of. And then you have an output which is based on the input values. So you obviously don't want to have different output files for the same input file, or you don't want multiple inputs to end up at the same output. So a good trick is usually, or a good like rule of thumb, is to base the name of the output on the name of the input so that if anything gets messed up, you will at least be able to notice it. You'll be able to see that the output came from this input, so calculating it like this. So this would be taking the input file, taking off the BAM extension, that's what this does, removes the BAM extension, and then it says .output.q and then the Q filter value that you gave it. So now you have each combination of your two first arguments helps determine the name of the output file. And here we're just echoing what we would run. And I think that's always a good idea, is to echo what you are going to do, the computed things. Like the more complicated the computations you're doing, even just this is complicated enough that I would echo it before moving on to actually running this runnerscript.sh. So this could be any of your bioinformatics tools, by the way. I just named it runnerscript.sh. So you have your input, you have the output that we calculated up above here, and you can use that Q filter. I explained what this does in one of my other videos, the one about how I organize my bioinformatics work. This takes standard error and standard out, so both of the outputs of this script, and put both of them in the same log file. That's all that does. And then that's what the script does, is it calculates what the inputs and output files should be and so on, and runs it. But here it only echoes, and that, like I said, is important to do the first time before you run it officially. So let's make sure to copy this. Oh, I have a Google Translate things on when I highlight text. It's a Chrome extension, but this is pretty cute because it thinks that this is Luxembourg-ish, which I didn't even know was a language. So that's pretty funny. So let's copy that into the command line. And now I'm going to go copy how I was going to run it, and I can show you what that looks like. And I think the easiest way to explain this, I mean, we've gone over all of these things before. We do launch runner script. Number one is going to be the inputs, right? We want the first one to be inputs. And again, note here that there's no $sign in front of these curly brackets. That can be a little confusing to some of us who are really used to doing bash, but we really don't want bash to insert something specific here. We want parallel to read this and say, oh, that's the first set of inputs. And then the second set of inputs is over here. And so these are going to be the Q filter values. We will have 3 different values that we try, 10, 20, and 30. So now you can see how we're launching this runner script with each of the different input files in 3 different ways each, with different quality filters. And so you can glance at each of these and see that it makes sense, right? One of these we have like, okay, we have input number 4, we have Q20, the output has input 4 Q20 in it, so we don't get confused. It is an output BAM file, excellent. The filter value is 20, and then we're going to output it to this log. Now, it's not actually output into the log right now because we put everything in quotes. So of course, to actually run this, you would simply remove the echo and this quote and this quote, and now it would actually run this. So this is a really good use case for parallel for those of us doing bioinformatics that, you know, we want to launch a lot of jobs with different combinations of parameters and so on. You can also see these details again in the blog post I showed you, which is right here, omgenomics.com/parallel. That's all I wanted to show you for this tutorial. Hopefully this gives you a good idea of how parallel works. Thank you for watching. If this was helpful to you, I would love it if you left a comment letting me know that. It's always very motivating to me and helps me get motivated to make more videos. If you'd like to subscribe to the channel, you can do that here, and I'll also post a video that YouTube thinks you'll like. And here's a video about how I organize my bioinformatics work, which I think I mentioned once or twice in this video, so I think that's a useful one to see if you haven't already watched it. So thank you so much for watching, and see you next time.